Let me introduce our first speaker then, David Gee, from the Centre for Pollution Research and Policy of Brunel University in London. I could say a lot more about David. I'll leave it to him to add something that I haven't said, but the only thing that I want to say is that he is probably best known for his great work in editing 2 big volumes of late lessons from early warnings, part 1 and part 2, published by the European Environmental Agency in Copenhagen. And particularly the second volume is a long list, I think it's over 700 pages, a long list of technological problems that we've seen in modern times, which science had given early warnings for, that weren't properly attended to. That was a great work. I like to call it the Bible of Precaution, those 2 volumes. It's available from their website. Without further ado, David, the floor and the screen are yours.
So I've pressed share screen, and does that mean you've got, wait a minute, no, here it is, yeah, try that one. Does that mean that you've got the slides there, I wonder? Share. There we go.
Not yet.
Not yet, no.
It's coming on. Yes, there we go. Pick your first slide.
My screen has got sort of 6 or 7 slides on it rather than 1. I think I need to do something about that, don't I?
You see your PowerPoint. Just pick your first slide and then press double click.
Hang on then.
Double click on it.
Yeah.
Yeah. And now at the bottom right-hand corner, the last icon of the 4, I think, that one. Yeah. That should do it, I hope.
Okay. So I've now got 1 big slide there. Has everybody else got the same?
No, we haven't got it yet.
Oh, okay.
Yes, we've got a slideshow at the top of the menu. So
Press.
for some reason that works.
Press slideshow at the top of the menu.
No, it's not. No.
It's fine.
I pressed new share, and now he's got back to, yeah, okay, share. So what have you got there now? What can you see?
This is it. Perfect.
We have it.
Go ahead.
Okay, so if I do that, yeah, okay. Right. So today, very quickly, I want to share with you an approach to establishing a sufficiency of causal evidence to justify intervening in order to reduce harm to people or planet. And it's an approach that was written in 1965 and is enduring for reasons that you will see. So in the lecture, I will do 5 things. Briefly share with you the Bradford Hill approach to establishing a sufficiency of causal evidence in public health. Very quickly show how it can be applied today to a controversial issue, head cancers from mobile phone use. Share with you some typical misinterpretations of the approach. Suggest a few ideas about how we might update it in the light of the current knowledge of complexity and multi-causality, which wasn't there when he wrote his paper in 1965, and to briefly mention the precautionary principle, which is a theme he didn't explicitly address, but which is implicit in his whole approach. The paper was called Environment and Disease, Association or Causation. And the only quibble I've got with this brilliant paper, which reads so well today and is very elegantly written, very accessible to non-experts, is that little word or, which I shall come back to. He says the cause of an illness may be immediate and direct, or it may be indirect and so on. He wasn't too interested in that cause, why things happen, why does A cause B, i.e. mechanisms of action, because he knew, being a big public health person, that our knowledge of whether A causes B arrives much earlier than our knowledge about how it happens. So John Snow discovers that polluted water causes cholera in 1854, but it was 30 years later before Koch established why it happens. So he wasn't too fussed about mechanisms of action. And he said the decisive question, therefore, is whether the frequency of the undesirable event B, i.e. the harm, will be influenced by, notice that nuanced word, influenced by, not the stronger word cause, by changing an environmental feature of A. And what aspects of that observed association should we especially consider before deciding that the most likely interpretation of it is indeed causation? So in other words, in what circumstances can we pass from an observed association to a verdict of causation? And in helping him and us to do that, he established 9 features of the evidence. He never used the word criteria, but when you Google Bradford Hill approach and you get hundreds of thousands of references, many of them are criteria. He was more nuanced than that. Criteria is very black and white, yes, no, whereas a feature of the evidence is more nuanced. And his basic point was to say that if the 9 features of the evidence were present, then it would justify a robust causal inference. But it doesn't work the other way around. If they're absent, they do not provide robust evidence for a non-causal phenomena. And he explicitly mentioned that when addressing 5 of the 9 features. What are the features? Well, here they are applied to the current controversy about head cancers and mobile phones. I'm not going to go into the detail of that latter part, just to race down and show you what the 9 features of the evidence are. Strength of association, consistency of results, specificity of effect, temporality. In other words, does the putative pollutant appear before the harm does? And then biological gradient, and then biological plausibility, coherence of the totality of the evidence, experiment. If you remove aspects of the pollutant, do things improve? And then lastly, analogy, where perhaps you've not got much evidence at all, except a very strong analogous example. For example, nanoparticles are of the same size and shape as asbestos particles. Therefore, that's a strong bit of analogy evidence that he could use. When the people who did the paper that I quickly romped through there, Hardell and Karlberg, applied the 9 principles, the nine features rather, to the stock of evidence on head tumors and mobile phones, they conclude that it should be an IARC class 1 human carcinogen. And that was written in 2017, before the very, very strong and powerful animal evidence that came out in 2018 and 2019. Many of people don't believe that non-ionizing radiations can cause cancer. They are, as it were, not as good scientists as Pasteur would like them to be, which is to have a prepared mind for a complete, as it were, scientific surprise. Bradford Hill said, our main objective is therefore to take action to try and intervene to abolish or reduce death or harm. And he noted that all scientific work, of course, is incomplete. Science marches on, but that does not give us the freedom to ignore the knowledge we have today or to postpone the action that is needed. And for that, he said, you therefore need differential standards. By that, he means different strengths of evidence. And here are the 3 illustrative ones that he gave in that 1965 paper. There might be relatively slight evidence, he said, for a pill being given to hundreds of thousands of women for pregnancy, early warning sickness, etc. And if the slightest evidence appeared suggesting a teratogenic effect on the fetus, then you'd ban the pill. And if it turned out to be wrong, so what? Just the profits of some companies will be affected, etc. Whereas if he didn't act, and of course he had thalidomide very much in mind in 1965, the thalidomide tragedy was 1962, gross deformities of children. So he said that if the stakes are of that sort, that a gross harm, you would perhaps just use a slight level of strength of evidence. In the middle, fair evidence, perhaps for eliminating an exposure to a probable carcinogen in the workplace, whereas he said governments would probably want to have very strong evidence before they intervened to make people, ordinary people, stop doing things that they like using fossil fuels in their homes, or smoking, or eating fats and sugar. He was very advanced. Now, some typical misinterpretations, they're all written in this paper that we produced after my last workshop on Bradford Hill, which was at the Royal Society of Medicine in 2017. And this paper summarizes these features, which are the common misinterpretations of the Bradford Hill approach. In other words, firstly, people wanting yes, no criteria. That was never his aim. He was more nuanced than that. They demand all of Hill's features to be present. They ignore asymmetry. I'll come on to that. And they require consistency. I'll mention something on that. And you can see there the rest of them, requiring statistical significance and a doubling of the risk at least, in other words, a relative risk of at least 2. And these are all the standard arguments, misinterpretations of Bradford Hill, used principally by the lawyers for the companies in US tort cases. But do we need to update his wonderful piece of work, which is used by lots and lots of people still? But in light of complexity, multi-causality, variability, and so on, and improved scientific methods, should we update them? There's a couple of good references there. I'll skip past that one. So the main updates that I want to focus on are, firstly, ditch dichotomies and embrace continuums. I'll mention that again shortly. Strengthen the asymmetry of the evidence, weigh some of the features differently, reveal the misunderstandings that I briefly alluded to earlier, increase the differential standards, or the 3 strengths of evidence that he put in his paper, to 8, to reflect the continuum from low to high strengths of evidence that we need to use if we are to avoid harm. And use transparent terminology and common understandings. There's a paper on that called The Language of Links. I won't be able to discuss it now. I can share it with you at some other time. At the time of the controversy between 1950 and 1964 about does tobacco cause lung cancer, the language used is interesting. It's a mixture of the word association and causation. In other words, those people there were using a kind of continuum and were not wanting to say, is it association or causation? Look at the language. The first paper by Doll and Bradford Hill. We think we have found a real association. And look at the response of the Medical Research Council 3 years later, when they decided that Doll and Bradford Hill were right. Tobacco does cause lung cancer. Look at the language. A major part of the increase, not totality, is associated with tobacco smoking. And when we look at the evidence, a reasonable interpretation seems to be that it could be direct cause and effect. And when the magisterial report from the US Surgeon General came out in '64, which settled the question very clearly, they too used both words. Does the association have a causal significance? And this point about whether we go with dichotomies like either or and association or causation, nature or nurture. A nice piece from epidemiology comes in from Sander Greenland, who says there is too much dichotomy going on. In other words, whether a p-value is statistically significant or not, and either or. Scientific life is more nuanced than that. And similarly, when you begin to think about this, you find that many people use dichotomies, and many of them are there, and they're not really dichotomies, they are continuums. They are continuums along a gradient. Those earlier examples came out of these 2 late lessons volumes, which have been mentioned. They're the chapters, and I'll move swiftly on. A key big point about the whole approach of Bradford Hill, which he explicitly recognized, but which is often forgotten, is that they are asymmetrical. If present, they support a robust causal inference. If not present, they don't. And here's an example of one of the 5 where he explicitly acknowledges this asymmetry of his features. So he never used the actual word asymmetry, but here he is saying, well, biological plausibility is nice to have, but remember, it depends on knowledge of the day, and it's a feature of the evidence we cannot demand, because an observed association, of course, could be new to science or medicine and must not therefore be readily dismissed. Looking at the features now and thinking about how we might update them, the strength of association, we will probably not put so much on that because we know that relative risks of less than 2, like heart disease from smoking, are robust findings. Consistency would be downgrade because we realize with complexity that you will get inconsistency. Specificity, i.e. does A just cause the one harmful effect, B that's now not recognized. For example, tobacco causes 7 or 8 kinds of cancers and lots of other problems as well. Temporality, obviously A must come before B, but it can be misapplied, as the WHO did in its report on endocrine disrupting substances in 2002. Biological gradient, nice to have, but we now know about non-linear dose response, and we know about low dose effects, so you downgrade that one as well. Plausibility, a greater knowledge of possibilities emerges from molecular epidemiology and so on. So we have a broader recognition of plausibility. It's the same point really for coherence. And with epigenetics and co-causal factor analyses, we can strengthen the experiment one. And analogy, often in complexity, with complexity, we don't have very robust evidence for A causing B. So if we look over our shoulder at something that's analogous, then that could be a very useful piece of evidence. He was very strong on misuse of statistical significance. He says we often lose the substance when we insist on statistical significance. Very often, robust evidence can not involve statistical significance. Consistency, he also emphasized, was not as essential. And now in the context of complexity, we realized that we would expect inconsistency of research results from complexity. And a nice exposition of this comes from Herbie Needleman, the hero of the lead in petrol story, who said, consistency in nature does not require that all or even a majority of studies find the same effect. And he thought if all studies of lead, and he was an expert in this, showed the same relationships between variables, one would be startled, perhaps justifiably suspicious. And there's another reference to the same point below. As I mentioned, he didn't want to wait for knowledge of mechanisms of action, i.e. how A causes B, and this is his comment on that. How such a change exerts the influence may call for a lot of research. However, before deducing causation and taking action, we don't have to sit around and wait for the results of that. We might wait for 30 years before knowledge of mechanisms of action. No evidence of harm. Not, yeah, go into it. No,
how much longer do you want? We started a bit late, so you can have a few more minutes, but how much longer do you want?
Yeah, 4 minutes, that's fine.
Okay, go ahead.
Remember a classic here, no evidence of harm, which is often stated, is not evidence of no harm, for obvious reasons when you come to think about it. But you frequently see on the media grey-haired experts saying there is no evidence of harm, and it sounds plausible, but the relevant research has not been done. And then here's some a reference to language, which I mentioned is important. Here's an example of a risk assessment done on neonicotinoids and bees in France, where the team of experts wanted to demonstrate that gaucho, the relevant pesticide, was solely responsible for all the damage. This is just rubbish. It's putting the standard of proof far too high. And luckily, the Minister for Agriculture in France dismissed this French Commission for Toxic Products for that unrealistic conclusion, and he set up another one called the multi-factor study of honeybee colony decline, and there they said in the context of multi-causality and complexity, the most we can say at the moment is that gaucho is of concern as just one of the explanatory elements that causes damage to bees. And on the basis of that, plus the precautionary principle, the French minister banned the neonicotinoids, and he was 10 years ahead of his time. Finally, how much strength of evidence do we need? I mentioned earlier the 3 illustrative examples of Bradford Hill, fairly slight, medium, and a lot. Now we think we need perhaps about 8 types of strength of evidence along the continuum from the bottom, very low, to the top, very high. And then it becomes an ethical choice as to which one we choose to justify action, depending on the consequences of being wrong in either acting or not acting. And I think I'll stop there probably, but maybe on this one, because this is a generic answer point. Corporate donations to universities and the resulting institutional conflicts of interest. Big problem, discuss. And there I'll end. By the way, there's about 70 slides in there, 2 other illustrations of the current use of the Bradford Hill with something called aerotoxic syndrome and with glyphosate, but they're in the total package of slides that I've sent through to you. Thank you very much for your time.
Thank you, David.